Picture this. Classic spanning tree protocol, STP for short, can drag its feet for a painful 50 seconds to get everything back on track if a link decides to take a nap. In the digital age, that's like standing at a bus stop for an eternity, waiting for a bus that never shows. But don't worry, Rapid Spanning Tree Protocol, or RSTP, swoops in like a superhero under the IEEE 802.1W standard. It chops that waiting time down to less than a second, ditching the old, slow timer method for a swift proposal agreement handshake. And here's the great part. RSTP is backward compatible with 802.1D, becoming the new standard everyone's cozying up to. Cisco gives it a little extra flair with Rapid PVST+, which operates per VLAN. If you're aiming for your CCNA, getting a handle on how RSTP speeds things up compared to the classic STP is a must. RSTP, or Rapid Spanning Tree Protocol, really streamlines things by reducing the number of port states from 5 down to just 3 and introducing some new port roles. In the old school STP, you had a whole lineup: disabled, blocking, listening, learning, and forwarding. RSTP simplifies that into 3 states: discarding, which combines disabled, blocking, and listening into one, learning, and of course forwarding. Now onto the new port roles. The alternate port is like your spare tire, ready to take over if the root port fails, all set and pumped up to go. The backup port is more of a plan B for a designated port on the same network segment, always there just in case. But the real revolution here is the proposal agreement mechanism. Instead of twiddling thumbs waiting for timers like STP, RSTP switches have a quick chat to sort out roles. It's like skipping the traffic light wait and getting straight to driving. Let's dive into RSTP's 5 port roles. First, we have the root port. Picture it as the VIP lane on every non-root switch, offering the quickest path to the root bridge. Next, there's the designated port. Think of it like the designated driver for each segment, guiding traffic efficiently toward the root. Then we have the alternate port, the unsung hero standing by. It's like a standby taxi, ready to jump into service immediately if the root port fails, skipping the usual waiting around. Now the backup port is a bit different. Imagine it as a spare tire on the same segment, a backup option alongside another designated port on the same switch. Lastly, the disabled port is what you get when it's manually shut down. The real magic is in the alternate port's ability to help RSTP converge quickly, as it skips the listening and learning states entirely. Let's dive into some RSTP gotchas that can catch you off guard. First, there's the discarding state. RSTP uses this as a catch-all, rolling together what STP calls the disabled, blocking, and listening states. So don't be fooled into thinking these are separate like in STP. Now keep in mind, RSTP is backward compatible with STP. If it encounters an STP switch on a port, it'll adjust and play nice, acting like STP on that port. Think of it like someone switching languages to keep a conversation going smoothly. Here's another one: alternate ports. In RSTP, these are like the non-designated blocking ports in STP, but with a twist. They don't deal with timer delays, so they converge right away, just like zipping through a fast lane in traffic. Lastly, Cisco's Rapid PVST+ is the norm on modern iOS switches. It's the chef's special. To see what's cooking, use the Show Spanning Tree command. It's your trusty tool to check what's running. Keep these points in mind, and navigating RSTP on the exam will be a breeze. And there you have it, RSTP, the spruced up version of STP. We've walked through the 3 port states, the 5 port roles, and how it zips along with super fast convergence. Now go tackle some practice questions at Courseiva.com. You've got this, and I'm rooting for you.